Secrets to successful soil. I love the alliteration here. Really, the secret to successful soil is just keeping it simple. And so we're going to talk a lot about that here in the next 45 minutes. So I've really broken today's talk into two main parts. The first is managing for long-term health. Yes, you can, there's so many ways we can manage the soil, and some of it might work in the short term, but I really want to think about it in the long term. I want to talk about ways that Utah is unique, which means that we need to be very about out-of-state recommendations. And then I want to finish up on really fun things about how can we really promote soil health and build up healthy soils. So healthy soils means healthy plants and healthy us. So the first tip, take out-of-state recommendations with a grain of salt. So many of those gardening tips that go viral are coming out east. And here in Utah, things couldn't be more different. So as an example, I've got this rather boring looking table, but I promise to me, it's really fun. And it's just comparing what conditions are like on the US coast or in the Midwest compared to Utah and in the Intermountain West as a region in general. So first off, the coast in the rest of the US has it pretty easy in terms of temperature. It's mild. Their daily temperature fluctuations are not very strong like ours. I mean, in a given day, our temperature can easily fluctuate 30 degrees or more, whereas that's not the case around the US. We also have really strong microclimate here. And so what I mean by that is that it can be really different at my house, and I can drive a mile away in the valley and I can encounter completely different conditions. That actually, I experienced that yet again this week with the windstorm and how that hit Cache Valley. So there's also humidity is different. We are in a semi-arid climate. We just don't have the humidity that the rest of the country has, most of the rest of the country that is. We're also at high elevation, which means our sunlight is extremely intense compared to most places, and that has an effect on plant growth. So if you think about it, we have about a mile less atmosphere by living up in the mountains. And so that means our sunlight's very intense, but also beautiful. But really thinking about the soil and water, we have, our soils have a high pH, or they're considered alkaline. So the pH scale goes up to 14. 7 is considered neutral. That's really what plants like. A lot of the country is on the acidic side. So less than 7, but we're on the alkaline side, greater than 7. I think our state average is somewhere like 7.5 to 8. The other thing is that we have a lot less natural organic matter in our soils, and it's just because of the climate that we live in, and over thousands of years, our soils grew in different ways than the rest of the country has. So it's really common for soils out east to have about 5% organic matter. Whereas here in Utah, we have less than 2% on average. And so right away, that's something that we're gonna wanna manage a little bit differently than the rest of the country. We also don't have the rainfall like the rest of the country does. And so our ability to hold nutrients in the soil is actually a lot greater. And that can lead to an accumulation of nutrients, which can also lead to an accumulation of salt. And that's something a lot of gardeners outside of this region don't think about, but we have to. So these are just some things to think about, that we are a unique place. I always say our gardeners and farmers have to be the best in the country to deal with all of these different conditions. And so for that reason, I am always leery when I hear out-of-state recommendations, and I start thinking about how will that actually play into Utah. And so we'll kind of be touching base on this throughout the next bit of time. So my second tip is to be aware of your soil's fertility and what nutrients you're adding to avoid over application. That's a mouthful. But what I mean by that is that because we don't have the rainfall that a lot of the country does, the nutrients really like to accumulate in our soil. And so plants are constantly using nutrients, and we have to make sure that we're maintaining soil fertility. But it can be really easy to add too many nutrients, and that's actually can be a problem. So let's just step back and admire all of the things that soil does for our plants. Plants need 14 mineral nutrients from the soil in order to be healthy and to grow well. And it's just amazing to step back and think that the soil provides all of these. It's just this amazing bank for nutrients for plants. We divide nutrients into two main categories. The first is macronutrients, and macro means big, or the plants need these in large quantities. And then the other is micronutrients, so needing them in smaller quantities. And I've highlighted a few in orange here because these are ones that we tend to need to manage a little bit more. Now, quite often micronutrients are just fine at just fine levels in the soil. Sometimes they can become an issue depending on our pH. But the things we really want to think about every year are what are our nitrogen or N, phosphorus, P, and potassium, K. What's our NPK in the soil? And so we'll touch on that here for a lot of the session. So, okay, so the soil is supplying all of these nutrients to plants, 14 mineral nutrients. The plants need all of these in order to produce appropriately. So if my plant is low on nitrogen, it doesn't matter how much extra phosphorus I apply, the plant's just not going to do as well. It needs the right quantities of all of these things. So I highly, highly recommend doing a soil test. This is the best thing to do to just get a baseline on your soil. If you've never tested your soil, I highly recommend it. It's an investment that's very worth it because there's really no way to look at the soil and know what those nutrient levels are at. And a lot of times when people do this, they find that actually their soil has sufficient nutrients, that they don't really need to be adding more. So a soil test is an opportunity to know exactly what your crop or your plants need. Like I said before, that there's 14 nutrients that all plants need, and if even one is deficient, the yield will drop off, or the productivity of the plant will drop off. It can be tempting to just look at a plant and see if it might need nutrients. So I've got some pictures here. Here's a study on corn, and you can see that there's a nitrogen deficiency, for example, on the corn on the right, where the stuff on the left looks great. Here's maybe a phosphorus deficiency in some seedlings here. But the problem is that if you just rely on visual symptoms, it can be too late. And it's easy to misdiagnose what nutrient deficiency is out there because many can kind of look similar. So a soil test keeps us from that. And at the same time, it also helps us avoid applying too much. So a lot of folks can find that by doing a soil test and realizing more nutrients are not needed, you can then save money on things that we're buying at the store, whether that's fertilizers or many of the products that get marketed to us. Plants want to grow, soil wants to support life, and I think it's easy to get caught up in needing to buy all of these different things to make plants grow. But in reality, we can keep it pretty simple. Plants need these basic nutrients, and we just want to make sure that they're there in the right quantity and that we're applying the right amount. Now, a lot of these nutrients actually can behave like salts in the soil. So and we're going to be talking more about soil salinity here, but when we think about soil salinity, it's easy to think of table salt, which is sodium chloride. That's certainly a salt in the soil too, but then there's also many other things that count as a salt, and that includes plant nutrients. And so our goal is to supply just enough nutrients for the plant to be in an optimal level and no more. Otherwise, it can just be contributing to the salinity problem. And then you'll be sending your soil test report to me and asking what to do. And it's just nice to avoid all that on the front end by being careful with nutrient management. So a soil test is important, and these are the reasons why, which we've really covered there in that last slide. So okay, we want to test the soil. So the next step is choosing what soil test to do. If you go in maybe also what lab to pick for your soil test. And my recommendation on a soil test lab is just pick one in your state. So if you're in Utah, there's private labs. There's also labs through universities. Utah State has a lab. BYU has a lab. Both are fantastic. Just don't send your soil across the US to some other lab. And the reason for that is that these soil tests have actually been developed for the regional soils, the soils of the area. So we have different lab tests that we do depending on the soil type because they are so diverse across the US. So if I were to send my soil to Massachusetts, for example, they're probably going to use the wrong soil test on it because our soils are so different. So I'd just make sure you send it to a lab in the state of Utah. If you're in Utah, if you're in another state, find a lab in your state. And so, but anyway, so these are kind of things to think about in Utah here. Our soils tend to have low organic matter. Our average is 0.5 to 2%. This picture right here is a soil with very high organic matter. You can tell because it's very black. And organic matter is basically just dead plants and animals that have decomposed and become part of the soil. And so it's very nutrient rich, lots of benefits for the soil. This soil I'm holding here is about 9% organic matter. And I'm not saying we're trying to shoot for that, but if we can increase our organic matter, there's a lot of benefits for our soil. Most of our soils also have excessive levels of calcium carbonate. That's just the way they naturally formed. Calcium carbonate, also known as lime. So please don't buy that and add that to your soil. Chances are you probably have plenty. We also tend to have a higher pH, which can lead to certain deficiencies. And so it's a really great idea to think about this when selecting a soil test to see where your pH falls, because that can help diagnose other issues. And then we also have this issue of salinity to think about. So, okay, oh, here's my animation. Here's a soil, this is in my backyard. This is my soil here. And I think I have about, I'm trying to remember, 1.7% organic matter, something like that. So you can see that color difference too. Okay, so we've been dancing around this idea of salinity. And before I get into soil tests more, I just want to talk about what that means. So soil salinity is this presence of salts in the soil. Many things count as a salt. And there's a really fancy unit when the soil test lab gives you your results back, decisiemens per meter, doesn't matter. Our magic number is 2. So ideally, we really want to keep our soil salinity under 2. And so I highly recommend considering a soil salinity test just to get a baseline and see where you're at. It really helps inform what kind of amendments to add to the soil later on. So I've got these tables here of fruits. We don't have much data for flowers. And so that's something that actually my lab is working on right now. I do a lot of cut flower research. And then we've also got some vegetable types here. And so this is the level at which the plant starts to suffer. The production kind of goes down. It's a bit less healthy at these salinity levels. And so you can see for fruit, they're particularly sensitive, right? Apple, 1.4. But there are some vegetables that are actually somewhat tolerant to salinity levels, like zucchini and artichokes. But most of them are relatively sensitive. So magic number is 2. We want to try to keep our salinity below 2. And then there's exceptions to that. Seedlings tend to be more sensitive. So those are things to think about. And I brought up how many things count as a salt in the soil, not just table salt, which is sodium chloride, which is listed here. So these are common products that you can find at the store. And I have their chemical formula here just so you know what they are. And these are all cations and anions. These are all elements that add to our salinity. And so I'm going to read a couple here. Magnesium, that's a plant nutrient. That's a macronutrient. Calcium, sulfur. These are all, potassium is on here. So these are all plant nutrients. The plant needs them. But if we start having excessive levels in our soil, it's really not helping the plant. It's just adding to salinity. And so for that reason, I do not recommend buying these products to add. Gypsum, I wouldn't add. We tend to have excessive amounts of calcium in the soil. So if you need a sulfur source, just add sulfur to not have the increased salinity. Epsom salt, we just rarely see these deficiencies. So these are not helpful things to add in most cases. So given that, I just want to put an example here of the soil test lab at USU. But again, we're not the only lab that's out there. But here's a picture of our website. And I've also got listed here, it's usual.usu.edu. Usual stands for Utah State University Analytical Lab. And so if you go to this website, you can find there's many different types of tests you can do. So the home soil test is the one that I'm referring to right here, but you can also do water tests, you can do compost, you can do a bunch of different things. And so there's many different test packages that you can select from. This is what I would say as a minimum, this would be a really great thing to think about. And if you've never tested your soil, this is where I would start. And if you have tested it before, I would use this again to check in on it every couple of years. So phosphorus and potassium. Soils, our Utah soils, I see, especially for homesteaders and micro farmers and gardeners, the phosphorus and potassium can really build up. And so it's nice to check in. A lot of people find that when they do this is included in their test, that they don't need to add anymore. They only need nitrogen. And then the second one is the salinity. Sometimes we casually refer to it as EC, that's soil science slang. It stands for electrical conductivity, TMI. So, but anyway, salinity and pH, these are fantastic to check in on, especially if you're using compost. You want to see what, because that can increase your salinity and so forth. So these are really good ones to think about. The second tier, one time only, you don't need to retest this, but it's a good idea to figure out what your soil texture is. So how much sand, silt, and clay is in it, and that can affect management. This takes hundreds to thousands of years to change, so you really only need to test it once, unless you're bringing in a bunch of topsoil and changing your soil in some way. But texture can be really telling for how we can address management. And then these are some optional tests, but ones that can be helpful for follow-up. So we don't routinely test for nitrogen, which is the #1 plant nutrient. It's the one that we typically need to replace every year, but it can be helpful for diagnosing. If you were to get your initial soil test back and see that the salinities, or excuse me, the pH is high, that can help us figure out other deficiencies. So iron might become a problem with a higher pH. And then if you live in an urban environment, we have a test called the total elemental. It's an EPA test, and it actually tells us both micronutrients and heavy metals. So it helps us gauge contaminants in the soil like lead and arsenic, which can be elevated in urban environments. And that's actually an area where that I've been working on in my lab and in my research. So I just want to follow up that nitrogen is not routinely tested because we typically just need to add it every year. Nitrogen does not like to stay in place. It likes to go everywhere we don't want it to go. It likes to leach down deep in the soil, especially if we're overwatering. It likes to volatilize into the air. Just doesn't want to stay in that root zone. And also plants are using it pretty heavily. So we just have general recommendations for nitrogen if you're not testing your soil. And so we actually group vegetables, for example, into categories of needs. So there's a low requirement, intermediate, and high, depending on the vegetable. And then that kind of dictates how much you would be adding per 1,000 square feet. So, okay, so let's say that we've decided we're going to do a basic soil test. We want our phosphorus, potassium, salinity, and pH. Then the next question really is, how often should I sample? And our official recommendations are that if it's a perennial garden, you'd want to every 3 years. And if it's an annual garden, every 1 to 2. I don't mean to say that I have low expectations, but I say just do it once. Please at least try it once and then revisit it as you can every few years to check in on your management practices. Because really it tells you where your soil's at, how much you need to add, and no more. And so it's just a really nice, precise way to go about it to ensure soil health. But the goal then is, so now, okay, we're going to soil sample. The next thing is to think about, well, how are we going to collect these samples to actually represent our yard or farm or homestead? And that's what I'll be talking about here in the next couple slides. But before I go on, I just want to put this out there. I get asked about this a lot, and we really do not recommend the home soil test kits. They were mainly developed out on eastern soils, which we've already talked about are so opposite of what ours are. So our soils are special, they're different. Take it into a lab, get it tested, and you'll be sure to have a good result back. So This is an intense picture. It's looking at large scale ag. They're trying to get more precise when they're managing fields, but I like to argue that we can also be precise as homesteaders too. And so there's some things to think about. When you're picturing your yard, maybe think about it in terms of 3 different zones. And I'm going to get into that in the next, I'll show you an example at my house in the next slide here. But the idea is that if you're treating soil very differently in parts of your property, that should be its own zone. I treat my turf very differently than I treat my vegetable garden. So I wouldn't want those to be in the same zone, right? My turf is a zone, my vegetable garden is a zone, as an example of that. Also thinking about the history of it. What are you adding, manure or compost? What kind of fertilizer? These can all be ways to kind of think of the yard as different zones. And also use your intuition. If an area just seems different to you, maybe that should be its own zone to think about, especially if it's underperforming and trying to figure out why that is. Okay, so here's my house right here on the corner. It's old and lovely, and it looks quite different since this Google shot was taken. I think that's before I lived here. But let's see here. So I've got this bee garden. This is mostly perennial flowers that are growing here. Very low input garden. I call that one zone. Then I've got vegetables here. I actually now have them here on the whole south part of the yard. I treat the vegetables very differently. They get annual additions of compost. I have to add nitrogen every year. And then here in the front, it's kind of turning into an orchard. It was historically an orchard. There's turf. It's also on flood irrigation, which doesn't reach the backyard. And so this is all culinary. This is flood irrigation. With secondary water, there can be an increased risk of an elevated salinity. So that could be a reason, irrigation could be a reason to zone a certain way. And then I just added, there's some shrubs here. So this could be an example of zoning, for example. Here, I've got this another zone as a potential because my house is, gosh, it was built in 1918. It's got wood siding that's painted. And so I have a lead paint risk. I could have enriched lead in the soil. And so my goal this year is to do a test on the contaminants just to see where that is. And so that might be a place I don't want to put vegetable crops or food crops because of that lead. So, and then just more examples. My neighbor has this goat and horse pasture. So since there's this history of animals, this is just another example of how you might want to have a zone because they can increase the salinity. They can increase the nutrients too in the soil. So might treat this differently. So these are just examples. I have 3 zones. And so what I like to do is just kind of alternate then on my soil testing because it can add up. So maybe one year I test the vegetables, the next year I do the perennial flowers, and the next year I do the turf. And then that can be a nice way to spread the cost of a soil test. I want to show you another really neat resource. This one's free. And it can help you think about your yard in a different way as well. And it's understanding what the native soil is like for an area. So I know all of these slides, there's a printout of them, a PDF that you can download, and we can send out this link too, or you can type into Google the UC Davis Soil Web. And so basically what this is it's data that the NRCS collected back in the day. So the US government went and surveyed most of the soils across the US back in the day. And because they looked at what the texture was, what does that soil, the topsoil look like, the subsoil, and this is all mapped out. The federal government has a website. In my opinion, it's rather slow and cumbersome. So this UC Davis has some nice visuals. It's just a little more user-friendly, I think. And so this is what the soil is naturally like. If you've brought in a lot of topsoil, there's been changes with construction, this wouldn't be represented, but it can be neat to see what an area is like. Or if you're thinking of buying a new house, you can check out what the soil is like there. So here's an example of a map. You can so if you go to that website, you can type in your address. And it'll take you there, and then there'll be these yellow lines, which those are showing the boundaries of different soil types. Now, I have to say that back in the day, nobody was sampling every foot. So basically what they would do is they'd take a soil sample and then they would look at the landscape and they would kind of estimate where those boundaries are. So if you live near a boundary, I would recommend kind of hopping over and looking at all three because they're not exact. But then it just tells you tons of information. It tells you, you can click on it and it'll show you what the layers of the soil look like. So, and I'm sorry it's in metric. That's the one bad thing about this site. And then you can read more about it in English too to learn more. But to me, this is really great. I can see that my topsoil here, this A horizon, that means topsoil, organic matter. It goes pretty deep. It's over 10 inches deep. I can see that there's clay in the subsoil, so I might need to worry about drainage. I can click around and see how much native organic matter there is. And it's saying, oh, there's about 2% here at the surface, and then it gets really low at depth. That's pretty typical. I can see where the clay layer is. Where does that clay pick up that I might have to worry about for drainage? I can see the pH, what's the native pH of the soil, pretty lucky here, just over 7, and then it increases at depth because of the lime that's in the soil naturally. And it just, the list goes on. And so there's a lot of great information. If you use this website and have any questions about your soil, I'm happy to help interpret this and help you with that. But it's a neat free source to check out. So, okay, we figured out our zones. Maybe we've got a couple different soil types going through, so we want to zone those separately. The next thing is to take your samples. And so my favorite quote from Grant Carden, our soil specialist in Extension, is junk in means junk out. So do take the time to do a good sample because the test results can only be as good as the sample that gets sent in. So what you want to do is when you're figuring out your zone, maybe this is my zone right here, for example, I don't want to just dig and take soil from one spot. What I want to do is have a bucket with me and take a sample at a couple places. So maybe I have a raised bed, for example, that's just been underperforming for some reason. Well, then I'd want to take samples from a few places in that raised bed, mix them all together, and then the soil test lab, no matter where you go, they really only need 2 cups of soil for the basic test. And so the reason for this is like, I just don't know what happened in this one spot. If I only sent in a sample from here, maybe a dog came by and peed, and that's going to change the salinity and the nitrogen and so forth. Whereas if you can do a few subsamples, mix them together for a zone, then it gives you the average across that zone. We recommend going for a garden, we generally recommend going down about 12 inches if you can, but a shovel's depth is okay too. This is the hardest field I ever had to sample. We had to take hundreds of samples that day, and the ground was it's an alfalfa field. The ground was so hard, we had to use a rubber mallet to get the sampler in. Hopefully your soil's not that hard. Then the next step is just to follow the soil test recommendations. So different crops require different amounts of nutrients. There's a lot of places that nutrients can come from. And some considerations for soil, for nutrient sources are, generally speaking, most people will find that they have plenty of phosphorus and potassium in their soil. And so I've got some examples here on the next slide. I'll skip right over to that. So here's some example products. I mean, there's a lot of them out there. If you go, it can be kind of overwhelming at the store of all these things that you can find. I'll just put them all out there. And I feel like fertilizer companies do a really great job of advertising. The more expensive the product, the more artwork they put on the front. But what I would encourage you to do is to pay attention to those 3 numbers on the bag. And sometimes it can be very hidden, but they always stand for the same thing. The first number is nitrogen, the second number is phosphorus, and the third number is potassium. And so if you have plenty of phosphorus and potassium in the soil, what you're looking for is a product that has a big first number and small second and third numbers. Okay, otherwise you're just adding more P and K and it's not needed. And sometimes you have to really look for it too. It can be buried on the product. The second thing is to turn it around and read the fine print. So I like to use this example from Dr. Earth here. I'm not in any way advising its use. I don't care for it because it's 463, at least a lot of times, you know, again, we don't need the P and K, so it's not so balanced for a lot of needs, but I like it as an example because if you turn the bag around, you'll see it says 4% water insoluble nitrogen, 6% available phosphate, soluble potash. So these words, total, insoluble, available, soluble, have a meaning. Insoluble means that it's not available to the plant right away. It's got to break down first. So if I need nitrogen, this is not going to help my spring planting very much because none of this nitrogen is available. All of it is actually insoluble. Whereas the word available and soluble, that means that it's available to the plant right away. The plant can use that nutrient instantly. And so that's something to also keep in mind when making a decision. So we have a few fact sheets I just want to plug that can help walk you through step by step how much nutrients that you actually need. And it seems complex, but it really isn't. And so these are some nice ones to think about for selecting soil tests, and then also how to interpret the lab results. But I just want to show an example here. And I know equations on a Saturday on a beautiful day, our presentations go to die, but hang with me for a sec here. There's a lot of questions with this. So the soil test says you need 2 pounds of nitrogen per 1,000 square feet in a garden. So what does that actually mean for a bag of fertilizer or compost or so forth? And so my example here is maybe we're going to use urea, right? It's got a big first number, small second and third number, so 4600. What I would do is use this equation. So how many pounds did the lab say? It's 2. And then I want to divide by the number on the bag. So I want to divide by 0.46, and then that tells me how much to add. So if I need 2 pounds of nitrogen, and I'm using urea, I only need 4 pounds from that bag. I need to just spread that 4 pounds across the area. Maybe I'm organic and I don't want to use urea. I want to use something like feather meal, which is 1200. All that N is insoluble, by the way, but it does break down. So 12%. So then here, what I would do is take 2 divided by 0.12, right? The number on the bag is 12 divided by 100 makes 0.12. So 2 divided by 0.12 is 17 pounds. And you'll notice that I need a lot more of this fertilizer than I do of that one because it's just less concentrated, right? There's only 12% of that bag is actually nitrogen in this case, whereas half of the bag, 46%, was nitrogen in the other. So I just need to add a little bit more. So it depends on what you're using, and you can figure that out exactly. I also have this handy dandy worksheet to kind of walk you through the process in the urban soil sampling fact sheet. So, and it's also printed here in your notes from the presentation. Okay, so I need to move along a little more quickly here, but that's the most complex part about it is do a soil test. The soil test is going to tell you how much to add, if anything, and then that's how you figure it out. And that's the way to be precise about nutrient management and not overdo it. It pays off so much in the long term. Sometimes products don't say how much there is for nutrients, especially compost types. If you're buying it from a commercial place, they by law have to have an analysis of that. So kindly ask them for it and they should give it to you in most cases. If they don't, I would go somewhere else. If you're producing it, you can actually get it tested. I also looked at all of the past manure and compost that our soil test lab has tested. And I made this handy table. There's a little fact sheet if you want to check it out. And here's an example of manure. I think the compost table looks very similar, but depending on what type of animal it is, the NPK, the pH and the salinity are different. And so manure, just to bring this up, manure can add salt, and compost, especially if it's based on an animal manure, can also add salt. So you got to be careful with that. Birds like poultry, so chicken, turkey, they have the highest salinity. And the reason for that, here's a picture of some chicken poop from my backyard. You can see the white that's on there, that's their urine. And that is what's really adding salinity to their manure. Rabbit and deer manure tends to be pretty low. And so if you're using a manure, try to pick one that's got a low salinity. Remember, our magic number is 2. you know, you add it once, it's probably not going to be a problem in most cases, but if you continue to do it. So trying to find one that's got a low salinity, one that's got a pH near 7, that's ideal. Then remember that compost and manure, they add nutrients and they also add organic matter, which our soils really need. And so I'm going to skip right ahead here about thinking about ways to add organic matter to our soils, because they very, very much need it, and that's going to add to plant growth. So adding compost is one option. And the challenge there is that we can add salt. So you have to make sure it's a low salt source. Check out that, I'll just skip back here. Ooh. Okay, okay, we'll just go ahead here. Okay, so there's a couple ways to do it. The first thing is that, I don't know if you've heard of cover crops before, but they can be a really great source of organic matter. They can also add nitrogen to your soil. And so we've got a number of fantastic fact sheets on cover crops. And so cover crops are something that we're growing more for the soil than for ourselves. And so they can be excellent to plant. You know, if you have a crop that comes off pretty early, like say onions or something that get harvested earlier in the summer, or garlic, for example, the rest of the season that soil could be bare. And so that would be a nice time to add cover crops, because they live, they die, and become part of the soil. So they're adding organic matter. When you add organic matter, it helps with compaction. It reduces erosion. It helps water get into the soil and stay there. And they can also help scavenge nutrients and suppress weeds. There's a little bit more on cover crops. Usually they're fall or spring planted. That's the most common. And then if you're planting in the fall, that's a common time to plant. You can pick ones that either die in the winter, or ones that don't die in the winter and they continue into spring so that the soil stays covered. And that can be really nice if you're gonna say plant tomatoes in that spot next year, and that's something that we plant a little bit later because of the frost date. And so you'd want that. It's a nice way to keep that soil covered and also give those weeds some competition. So cover crops that are considered legumes, those are ones that actually add nitrogen to the soil. So that can be a really healthy way to form your nutrient management plan. But for a legume to do its full job, you want to let it go as long as possible, which can be a challenge when you have a limited amount of space. And so generally we say to make sure you terminate it before the bloom stage so it doesn't become a weed. And then you're getting the most out of it too. So for cover crop, thinking about those, which cover crop is right for you, there's all of these questions to kind of ask yourself. One cover crop won't do everything. And I know we want to save a couple minutes here at the end for questions. So I'm gonna go through to the next slide here. I wanted to show you how beautiful cover crops can be, as just a great way to help manage your soil in a simple way, adding nitrogen if it's a legume, but adding organic matter no matter what kind it is. I'm going to skip through here on this example and just kind of summarize by saying, be careful about out-of-state recommendations. Try to test your soil at least once. Figure out where you're at. If you can check in every couple of years, that's even better. But it's really eye-opening for most people the first time they test to see how high the levels can be. Be aware of what you're adding. So thinking about manure and compost, just making sure it's a low salt source. Adding kind of sustainable rates, so maybe going easy on it, and thinking of other ways to increase your organic matter can be really wonderful. And keeping those cover crops in mind is yet another way to increase our organic matter. So with that, thank you all so much for listening this entire time.